In this video, I'm going to demonstrate how to create a digital input by using a button to say turn on an LED. So we need to add a few components here. So let's go ahead and grab an Arduino Uno. Just going to drop that in. Let's go ahead and grab a breadboard. Drop that in. We're going to need two resistors. So I'm going to grab a resistor, drop it over here, another resistor, and we're going to need, let's see, a push button and an LED. Okay, I'm going to hide my component window. Just going to organize this a little bit. So let's go ahead and rotate the Arduino around. Let's rotate the breadboard around, put them nice and next to each other. Let's start just wiring this in. So the button I'm also going to rotate around so that way the terminals are on the left and the right side rather than the up and down side or top and bottom. And then I'm actually going to span the button over this center column. So it's connected to columns on the left, A through E. So it's actually in column E on the left and column F on the right here. And then I'll just put somewhere in the middle, doesn't matter. And then I'm going to rotate my LED around, and I'm just going to pop that into 2 rows towards the top of the breadboard. Okay, then let's get our resistor in line here. So the first resistor we're going to run from the cathode, which is the top terminal if your LED is facing the same direction as mine. So we're going to run it from the cathode to the negative column here. So again, if you hover over the LED, you have both a cathode and an anode. That means that the LED is polar, which means that it matters which way you hook it up. A cathode is negative, an anode is positive. A switch or push button is non-polar, so it does not matter which way you connect it. What you need to know is that the terminals are connected across from one another here, from left to right. So then what we're going to do is we're going to go ahead and run the first pin on our negative column to ground on the Arduino. I'm just going to make that wire black. I'm actually going to run the first pin on the positive column all the way over here to 5 volts. So we give ourselves 5 volts. I'll make that red. The LED we're going to connect to pin 13. So that's a digital pin that could be either an input or an output. I'm going to make that wire, I'll leave it green. The switch here, terminal 11, we're actually going to connect to the positive column. I'll make that red. Red's now simplifying 5 volts. And then what we need to do is we actually need to create what's called a 1-0 generator. And to do that, we're going to connect this resistor to terminal 12. Actually, I'm sorry, we'll go diagonal. We're going to go to terminal 22, so it's connected diagonal here. Terminal 22 to this resistor. Then from this resistor, at the bottom of the resistor, we're going to go to ground. So that's our negative terminal. I'm going to make that black. And from the top of the resistor, right here in this row, where we're connected to terminal 22, we're going to run that. I'm just going to come off the board and come down and around to, let's just say, pin 8, digital pin 8. Again, that could be an input or an output, and I'm going to make this wire blue. So here's what we have. Let me see if I can zoom in for you a little bit. We have the LED connected, the cathode of the LED connected to the resistor, which goes to the negative column. We have the anode connected directly to pin 13. The switch, pin terminal 11, is connected to positive 5 volts. Terminal 22 is connected to digital pin 8 and a resistor. The resistor then runs to ground. Now, just to real quick explain what a 1-0 generator is. If you think about it, we have our positive 5 volts that's connected to a switch. And a switch basically looks like this when it's not connected. So I have these 2 points. When the switch is connected, this arm here comes down and it connects your points. And then over here, we're going to pin 8. If we didn't connect to ground, so imagine that we didn't put that resistor to ground. Basically what you're saying is, okay, when 5 volts is running through, when the switch is closed, it makes a connection from 5 volts to pin 8. The connection is sealed. When it's not running, when pin 8 is not connected to 5 volts, where's it pulling it from? Well, it would be floating in midair. So what we did was we ran it down to a resistor. So I'm just going to call this R1. And then we ran it to ground. And the symbol for ground kind of looks like this. Or I'm just going to say 0 volts. So if you think about it, a digital signal is either a 1 or a 0. When the button is not being pushed, this pin 8 is going to be connected to ground. Okay, it's receiving 0 volts. When the switch is being pushed, so this line would actually come down to here, it would actually make this connection. Well, then it's receiving a 1. It's connected to 5 volts. And this is called a 1-0 generator or a pull-down resistor. And again, this is basically just sending a solid 0 or 1 volts. If we didn't make this connection, if we didn't have this 0 volts down here, if this wasn't here, well then pin 8 would be floating in midair. And that would actually have floating voltage. So it wouldn't be receiving a 0 volts. It would be receiving a small signal like 0.1 volts, but still not 0 volts. You're not getting a solid signal. So you have to connect it to ground to make sure you're getting a solid 0 when the button's not being pressed. And the reason that the resistor works is voltage wants to go the path of least resistance. So when the button's not being pushed, it goes through this resistor, it goes to ground. When the button is being pushed, there is no resistor on the positive 5 volts. So therefore it's going to send the positive 5 volts. It's going to ignore the ground connection. Okay? Now if we go into our code editor, by default you're going to be looking at the block program. We're going to turn that off by pushing the block button. And I'm just going to delete all the code that's here. We need a few integers. So we need an int for the LED, which equals 13. We need an int for the button, which equals 8. And we need an int for the button val, which doesn't have to equal anything. So we're just going to call it button val and call it done. Void setup. We have to set up our pin modes here. So pin mode LED is a an output. Sorry. Pin mode LED is an output. Pin mode button is an input. And then we're going to go ahead and close setup. Void loop. What we need to do, we have to make this button val basically be reading the signal. And to do that, we're going to say button val equals digital read button. So button val is now going to read the signal from pin 8, right? It's going to be doing a digital read, and a digital read is of course either a 0 or a 1, and because we create our 1-0 generator, it's either going to be a 0 or a 1, depending on whether the button's being pushed or not. Then to turn the LED on using the button, we could say something like if button val equals high, equals high, digital write LED high. Okay, and then we just have to close our if statement here, and then I can do like an else digital write LED low. And then don't forget to close loop. Let's see if that works. So I'm going to start my simulation. I'm just going to drag this window down. So simulation is running, the LED is not on. If I go ahead and if I push the button, the LED turns on. Now, that again is just sending a basic signal to an LED. You could use this digital read to read any digital signal from a digital device, a button, whatever it is, and then you can do a digital write to an LED. You can do it to a servo, a motor, whatever you'd like. This is how you just do a basic digital input reading and then being able to use that as an output.